Welcome back, lab enthusiasts. Ever wondered why that pH reading fluctuates with temperature? Today, we're uncovering the fascinating relationship between temperature and pH levels in lab solutions. It's a topic with far-reaching impacts, from basic chemistry to biochemistry, agriculture, and environmental science. Before diving in, let's refresh on pH. pH measures how acidic or basic a solution is. It's a scale from 0 to 14, with 7 being neutral. Anything below 7 is acidic, and above 7 is basic. But here's where things get interesting. pH isn't constant, it can change with temperature. This variability is crucial when working with sensitive experiments, where precise measurements can make or break results. To understand how temperature affects pH, we need to talk about the chemistry of water. Water, H2O, naturally dissociates into hydrogen ions and hydroxide ions, OH burns. This balance between H- and OH- ions gives water a neutral pH of 7 at room temperature, around 25 degrees Celsius. Now here's the twist. As temperature rises, water molecules gain more energy, increasing their motion and the rate of dissociation. More H- and OH ions are created, but their concentrations shift enough to alter the pH. As temperature goes up, water's pH actually drops slightly. For instance, at 60 degrees Celsius, the pH of pure water can drop to about 6.5, making it technically more acidic than at room temperature. But remember, this doesn't mean water becomes harmful or corrosive. It's still neutral for that temperature because the H- and OH- ion concentration remains equal. Lower temperatures, on the other hand, reduce the energy of water molecules, slowing dissociation. At around 0 degrees Celsius, water's pH can rise to about 7.5. So in summary, as temperature increases, pH decreases slightly. As it decreases, pH goes up. This behavior is important for scientists to understand, especially in fields like biochemistry and pharmacology, where maintaining specific pH levels is essential for reactions. Why does this matter in the lab? First, in biochemistry, enzyme reactions depend heavily on stable pH and temperature. Enzymes function best within narrow pH and temperature ranges, so even minor changes can reduce efficiency or halt reactions. In microbiology, pH impacts the growth of microorganisms. Knowing how temperature shifts pH helps microbiologists prepare culture media accurately, ensuring optimal growth environments for bacteria or fungi. And in environmental science, researchers monitor pH in natural water sources. A river's pH can fluctuate naturally due to temperature changes, but without accounting for temperature effects, scientists might misinterpret these shifts, confusing natural variations with pollution. Most modern pH meters come with an automatic temperature compensation (ATC) feature. ATC sensors adjust pH readings by factoring in the solution's temperature. This feature ensures accurate readings even when your solution's temperature deviates from standard room conditions. If your pH meter doesn't have ATC, you can still manually correct readings by referring to standard pH temperature correction charts. When measuring pH, consider these tips. First, let samples cool to room temperature before taking readings, especially if they've been in an incubator. Alternatively, try to conduct measurements in a temperature-controlled environment. Also, always record the temperature at the time of pH measurement. It's a small detail, but it could be critical for your experiment's reproducibility. So, next time you measure pH, keep in mind that temperature could be quietly affecting your results. Adjust for it, use tools like ATC, and document your conditions meticulously. With these practices, you'll ensure accuracy in every pH reading. Thanks for watching. If you found this video helpful, hit the like button, subscribe for more lab tips, and let us know in the comments if you have questions. See you next time.